Hello everyone, welcome to Chemical Bonding YouTube channel. So today we will discuss on questions that is recently asked in CSIR-NET 2021 June exam. So it's from molecular spectroscopy, particularly from vibrational spectroscopy, and it was a 4 marker question. So let's see the questions. So in the questions, 4 statements are given, and we have to find that uh, what are the correct statements. So we will discuss every statement separately and try to find what are the corrects. So first statement says that if Q is the displacement from equilibrium for harmonic motion, the potential energy is proportional to Q. So we all know for simple harmonic oscillator model, potential energy is equal to half k into x square. V is potential energy, k is force constant, and x is displacement from equilibrium position. In the given questions, they used q term for displacement from equilibrium position. So we can see clearly that potential energy is proportional to x squared term, not x, or you can say potential energy is a even function. So statement 1 is incorrect. So if the statement says that potential energy is proportional to q square, then it was right, but they said that potential energy is proportional to q, so statement on is wrong. And what statement 2 says, it says that if the vibrational frequency of a diatomic molecule, that is HCl, is 2990 centimeter inverse, its 0 point energy will be 1495 centimeter inverse, means half of that vibrational frequency. So let's see. We all know the quantum mechanical energy expression for a simple harmonic oscillator model is epsilon v equal to v plus half nu naught bar centimeter inverse. So V is quantum number, its value from 0, 1, 2, 3 and so on. Nu naught bar is the wave number, and it's 1 by 2 pi c root over k by mu. K is force constant, mu reduced mass. Now what the we all know that the lowest possible quantum mechanical energy is known as 0 point energy. So in this expression, if we put V is equal to 0, then epsilon V becomes lowest or minimum value. So in that case, that value is known as 0 point energy for simple harmonic oscillator. So if we put V is equal to 0, then epsilon V become half of nu naught bar. That means half of the vibrational frequency of simple harmonic oscillator. So in the given questions, the vibrational frequency was given 2990 and 0 point energy is 1495. That is half of the vibrational frequency. So in the given case for HCl, nu bar is 2990. So epsilon 0 point means 0 point energy for HCl should be half of that vibrational frequency, means half of 2990. That is 1495 centimeter inverse. So statement 2 is correct. Now move to statement 3. It says that the correct order of vibrational frequency of OH1, OH2, OH3 is in the order. So they are given 3 OH bonds. It is a OH bonds, but they use 3 different isotopes of hydrogen. For hydrogen 1, the vibrational frequency is X1. For hydrogen 2 means deuterium, OD bond, the vibrational frequency is x2, and for OT means tritium bond, the vibrational frequency is x3, and they also given the order as x1 greater than x2 greater than x3. So let's see. We all know that the vibrational frequency of a harmonic oscillator is 1 by 2 pi k by mu in second inverse. If we convert into this vibrational frequency as a wave number, then it's become 1 by 2 pi c root over k by mu centimeter inverse. So we can say that the vibrational frequency is proportional to the force constant, directly proportional to the force constant, and inversely proportional to the reduced mass. But try to understand in this case that it is a OH bond. So for three different isotopes of hydrogen, the force constant value, that is K. For three different isotopes of hydrogen, the force constant value, that is K. Let's see, for OH bond it is K on, for OH2 it's K2, for OH3 it's K3. So this force constant value don't differ so much from each other because it is a OH bonds. Overall it is a OH bond, but they use different isotopes of hydrogen, 1, 2 and 3. So we can assume that for three case OH1, OH2, OH3, the force constant value means K1, K2 or K3, the force constant value uh, remains almost constant. So if this is true, then we can say that nu bar of these three types of bonds is inversely proportional to the reduced mass of that bond. So see, for OH1, OH2 and OH3, if the reduced mass of OH1 bond is mu1, OH2 bond is mu2 and OH3 bond is mu3, then we all know that the reduced mass of OH3 is highest and OH1 is lowest. So the order of reduced mass is as follows: mu3 greater than mu2 greater than mu1, and we all know that nu bar, that frequency is inversely proportional to the reduced mass. So the vibrational frequency of that bonds become in the order, that is nu bar x1 greater than nu bar x2 greater than nu bar x3. And in the questions they also given that mm, the order as x1 greater than x2 greater than x3. So x1 for OH1, x2 for OH2, x3 for OH3. So the reduced mass of OH3 is greater, that's why its vibrational frequency is lowest. The OH bonds for the reduced mass for OH bonds is lowest, and that's why its vibrational frequency is highest. So the of statement 3 is also correct. Let's move to the statement 4. So statement 4, to understand the statement 4, the fundamental vibrational transition of a diatomic molecule appears at 1880 centimeter inverse. Its first overtone will be at 940 centimeter inverse. So to understand this statement, we have to uh, learn some basic concept about harmonic oscillator and anharmonic oscillator model. So we just see, for harmonic oscillator model, the quantum mechanical energy is like that: V plus half nu bar centimeter inverse. But for anharmonic oscillator, the energy expression is like that: V plus half omega bar E minus V plus half omega bar E XE. So there should be one square. Sorry, just 1 second. So there should be on square term. So V plus half square omega bar E XE, where omega is equilibrium oscillation frequency, and X is an harmonicity constant. It is a small positive quantity. So we all know that for harmonic oscillator, the selection rule is del V plus minus 1. It means that for transition, the possible transitions are like that: V is equal to 0 to V is equal to 1. Transition will occur only two consecutive levels. Consecutive levels means V is equal to 1 and V is equal to 2. These two levels are consecutive. V is equal to 1, V is equal to 2. These two energy levels are consecutive. So for harmonic oscillator model, the transition is possible only two consecutive energy states. Means V is equal to 0 to V is equal to 1. V is equal to 1 state to V is equal to 2 state. So V is equal to 0 to V is equal to 2 energy state. This transition is not possible. And in spectra, for any transition, let's this transition let's assume this transition V is equal to 0 to V is equal to 1. So the energy difference of this transition means the energy difference between V is equal to 1 to V is equal to 0. This energy difference is appeared as a spectral line in IR spectroscopy. So for this transition V is equal to 1 to V is equal to 2, this energy difference is appeared as a spectral line. This is for simple harmonic oscillator. But for anharmonic oscillator, the selection rule is somewhat different. It's plus minus 1, plus minus 2, plus minus 3, and so on. But these three, plus minus 1, plus minus 2, and plus minus 3, are of considerable intensity. This transition have some considerable intensity. Other transition also possible, but they are weak intensity. So in anharmonic oscillator, the transition is possible. V is equal to 0 to V is equal to 1 state, it's also possible. V is equal to 0 to V is equal to 2 energy state, it's also possible. V is equal to 0 to V is equal to 3 energy state, it is also possible. So in IR spectrum, for first transition, V is equal to 0 to V is equal to 1, this energy difference we is appeared as a spectral line, and this spectral line or this transition is known as fundamental vibration frequency or fundamental absorption. So the energy difference for this transition is known as fundamental absorption, and this value is, if we calculate this value, it become omega bar 1 minus 2xe. If we consider this energy expression and put the value in this expression, first V is equal to 1 and then V is equal to 0, then you will get this expression omega bar 1 minus 2xe centimeter inverse. If you consider this transition V is equal to 0 to V is equal to 2, this transition is named as first overtone. So the energy difference between V is equal to 2 to V is equal to 0, this energy gap is appeared as a spectral line in IR spectroscopy, and that is known as first overtone. So if we put in this expression first V is equal to 2 and then, so see, you have to put first V is equal to 2 in that energy expression, then again you have to put V is equal to 0 and subtract this value, then you will get this value, and this is known as first overtone. 2 omega bar 1 minus 3 xe. Xe is an harmonicity constant. For this transition V is equal to 0 to V is equal to 3 energy state, this transition is known as first second overtone, and the energy gap is appeared as a spectral line, and that is called second overtone. And if we calculate the energy difference between this transition, then it will come as 3 omega bar 1 minus 4xe. So we have to consider this is the spectral line. This value correspond to the spectral line. This is fundamental, this is first overtone, and this is second overtone. So let's see the questions. So they gave that fundamental vibrational transition 1880 and fast overtune will be 940 centimeter inverse. Means fast overtune is half of that fundamental. And uh, they also and it is also given that anomalisity constant as 0. So we can assume that anomalisity constant as 0. So now for in the given case we can assume xe means anomalisity constant as 0. So fundamental vibration is omega by the 1 minus 2 xe. So we put here x is equal to 0 and it's become only omega bar e. And that is given that 1880 centimeter inverse. For first overtone, that is 2 omega bar e 1 minus 3 xe, we can put xe as 0. In the given case, so it was given that we can assume that anomalisity constant as 0. So first overtone, it's become only 2 omega bar e. So first overtone is double of the fundamental vibration. Means first overtone is 2 times of the fundamental vibration. So if fundamental vibration is given as 1880, so the first overtone should be double of fundamental vibration, that is 3760 centimeter inverse. But in the given question, it was given that half of the fundamental vibration. This first overtone should be double of fundamental vibration, but in the question it was given that half of the fundamental vibrations. So the options 4 is also wrong. So among these four statements, the option statement 2 and statement 3 are correct, 1 and statement 4 are wrong. So option C, A, B, C, option C is correct. So statement 2 and 3 only the correct statement. So I hope you will understand this every statements and how you will find that every statement is correct or incorrect. So thank you for watching. Stay safe, stay healthy.